Hi guys, so today a client of ours has asked us to send a sample scan of scanning a brake assembly. So what we're going to do now first is we're going to be using some of the marker dots as well as some of the stickers to put some markers in and around the brake assembly. They're also wanting the edge of the wheel arch, and this is to check for offset of wheels and that sort of thing. So we're going to put some markers down. We're going to scan everything here, and we're basically going to let you know how long it takes and walk you through the process of how you would get a good scan of this entire thing. Okay, so I'm going to start with the marker dice and try and get as much done as I can. Obviously, some of the components are going to be plastic and aluminium, so it's not going to work with the magnets, but I'll do as much as I can with magnets before resorting to stickers. It just helps things go quicker, means I don't have to peel the stickers off again. And let's see how long it takes to do that. We're going to be using the iScan Rigil for the scan. So it is one of the new scanners from Shining 3D. So we want to see how it goes on mechanical components like this. So we figure this is a really good test, not only for our clients to see that it's going to work for their specific use case, but for us to see how it works in this sort of case too. Okay, so now that we've got the scan itself off the scanner and onto our PC, what I'd done was actually mesh the model on the device itself. The Rigil's quite cool in that sense. You can actually just mesh it on the device, don't have to do it on the software. But if I had done this in multiple parts where I needed to go ahead and stitch, maybe one half to the other, then I could do that on the desktop software. But for this, because I did it all in one shot, I didn't really need to do that. So what I've done now is I've now brought it into ExModel, and you can see at the top there, ExModel Pro. ExModel is the reverse engineering software that we use. You can also use the likes of Quick Surface or Geomagic Design X, Geomagic Essentials. But the main thing we're going to be looking for here is just get that geometry that they were looking for. Now, this is going to change from case to case, depending on what your use case is. But for something like this, what the client was looking for was effectively to figure out what the offset from the face of the brake to the inside of the wheel arch would be, to figure out, the fitment of wheels, whether they're going to stick out from the wheel arch or sit inwards. So it was to design new wheels and be able to figure all of that out. So for them, we're looking for clearances there, also clearances to, say, the brake caliper and some of the suspension geometry that we've got on the back. So you'll see I didn't capture all of this stuff at the top because it wasn't going to be of massive importance, but the leading edge of the shock absorber, for instance, would be something critical because you wouldn't want the wheel hitting that. So with this, I'm not looking to recreate this whole thing, but I'm wanting to use it to pull some measurements from, compare some things, and just try and work out what sort of dimensions we need to be able to design a wheel effectively that would fit around this. So first things first, what I'm probably going to do is just create a couple planes on some of my flat surfaces. It's going to be the quickest way to get a reference point. So I'm going to use our face of the brake because obviously that's where the back of the wheel would mount to. So using the extract primitives tool at the top here, I'm just going to select some of the areas here. The more the better, you don't need to go too nuts with this, but it just uses this to approximate a plane that will then cut through that. So what I can actually do is probably create that, and let's maybe make it a little bit larger so that we can actually kind of see where it goes through the scan itself. And there we can see that's kind of where the face of the brake would sit in relation to the rest of the vehicle. Now that we've got this, we can do a couple different things. What I'd probably first do is we probably want the outer edge of the wheel arch just so we can see exactly where the wheel is going to sit in relation. So let me go ahead and sketch that up now. Now what I might do too to get some of the other geometry, I probably want to try and replicate a certain part of this, or at least have a bit of a sketch or something that I can pull through to give me an idea of where the leading edge of the brake caliper is, as well as the outer edge. So I think what I might do for this scenario is once again just create a plane using the leading edge of this. Yeah, that should be pretty good. Nice. Create, and once we've got this, what we can actually do with this is drag this through and actually use it to get a 2D profile. I do want to know where that kind of highest point is, so it's actually further back. So we want to pull this all the way through to about there somewhere, which is cool. So now if we go create on that, this is obviously one of our marker dice, so we're going to ignore that. And what I'm going to do with this is, because we're not, like I said, we're not trying to get anything that's, you know, radiused or anything too crazy, I'm actually just going to use a fit curve tool just to be able to mark out where that edge is back. And once we've got those, we could actually, if we're just wanting to have a bit of a surface to pull into the likes of SolidWorks or Fusion or whatever the case is, we can actually just go ahead and just do that, because now that'll come through as a surface body. Okay, so if we switch that off, we'll have that now coming through with our plane that we've got obviously on our brake face. And we can do that for any other geometry. We could even do just an extract primitives of, let's say, this tie rod end here. So once again, I'm just going to extract this. And for this one, I'm just going to tell it right that it's a cylinder. Great. And again, we could go ahead and create a plane front and back and, you know, dimension that off properly, but I'm just wanting to use it as a reference of, you know, where to avoid with the wheel. And I think lastly, let's maybe do the bottom bucket of the shock absorber. Don't think we'll need to go much further back than that. So what I'm going to do here is I'm just taking the furthest point, the part that kind of sits furthest out, and we're going to go ahead and recreate that. Okay, so now that we've got that, that's kind of going to be our front edge. It's, you know, anything further back or further behind is not going to interfere with the wheel. So once we've got that, I can just go ahead and just fill that surface. Yep. And on scan data. So that's as close to what we've scanned as possible, giving us the most sort of accurate representation of you know, the surface when we're checking for interference. Okay. So now if I switch that off, again, we've got a surface there that is a CAD surface. We can pull it through and we can use it for dimensioning. Obviously, what I would do in a situation like this is export the step file with all of our surfaces and planes and that sort of thing all intact. But then I would actually go ahead and, I haven't aligned this scan, but if this was all aligned to an X, Y, and a Z axis, you'll see right now it's not. But if we had gone and aligned it all, I would then go ahead and export the STL again so that the step file and the STL are in exactly the same location. That means that we can then open up the step file and overlay the STL if we need to for reference and that sort of thing. So the last thing I want to do is, just so that we've got a center line, we can actually go ahead and turn all of this, all of our wheel studs and our center ball, we can go and turn that into a sketch 2. So if I do that, it'll allow us to import all of our circle centers, center lines, and yeah, I'm just using the parts of the circle here to kind of generate our circle center. Perfect. All right, so once we've got all of that, we do have obviously a little bit of freedom that we could go ahead and just extract it up. So maybe just bring them to the top of the center ball. Right, so now we've got all of those in the right place, that by the time we go back into CAD, we've got pretty much everything we need to, including our upper lip here. We've got our back section there, so that we can take all of this in, and we've already got a bit of a head start. And we can then just start taking dimensions from this plane to the outer line, or whatever the case is that we need to work out. This will be also really good for race teams trying to figure out which wheels they can use to stay within regulation, or to maximize the amount of wheel arch that they do have available, or to be able to work out if they need to be running a wide body kit or whatever the case is. So there's a couple of use cases for this. Some might be for suspension geometry, but yeah, a lot of the time this sort of thing will be used for race teams, off-road vehicles, and the likes where the aftermarket, you're trying to make one thing from the aftermarket fit to something OEM. So that was just a quick look at how you can go about getting some critical geometry back into your current CAD system, whether that's Fusion 360, Inventor, SolidWorks, Solid Edge, you name it. We can export that file that we were looking at with all of our surfaces and sketches. We can export that as a step file, or if you're just wanting the 2D sketches, we can go ahead and do that with a DXF. Again, quite a universal file type. You could use ExModel to go and recreate the whole thing entirely. ExModel, obviously, that was just touching the surface of its abilities, but we can do things like advanced surfacing, freeforming. We can extract more primitives, and we can basically region out the whole thing to be able to go and recreate it part for part effectively. But for this purposes, we were just looking to bring in some references to check for interference. The Einscan Rigel did extremely well with this. I think it's also really important to mention, because of its small form factor and the fact that it is completely portable, it does allow you to kind of get in the wheel arch there quite nicely, quite easily. You're not fighting with cables. I didn't need power because, it's the one downside of a lot of the wired scanners is that they do not only require a laptop to drive them, but they do also require electricity to drive the scanners. So having the ability to go wireless is extremely beneficial. If we did have the ability to have a laptop down there, which I probably could have done, we could have done all of that completely markerless. It's important to mention that the Rigel does do marker-free laser scanning. Obviously, if there's enough geometry, a part like that, there is enough geometry to do it, but it does need to be tethered to a laptop to achieve that. So hopefully this is helpful if you're looking for a solution to be able to scan things and do something like this where you're just wanting to check if the product you're designing is going to fit, or if you just need to check basic tolerances and that sort of thing, that can also be done. Otherwise, if you're looking for a solution where you can go ahead and completely remanufacture something from scratch, that can also be done with the same sort of setup that we used for this video. If you require any further information, please feel free to contact us. I'll make sure to leave our contact information down in the description below. Thanks so much for watching, and we'll see you next time.